All right, so the topic today is there's basically two topics today. One is how to handle groups, how to have more control over how groups are handled, and then the other is how to handle themes. And you'll see what both of those things are in a second. So as I said a couple minutes ago, go ahead and re-execute chunk number 2 here to recreate this data set. And then we're going to jump down to chunk 15. Okay, so I think you've seen a couple examples where we've used a group's argument. But let's remind ourselves what that does. If I execute chunk number 15 here, where I've indicated that sex should be used as the group variable. Oops. Of course, we have to load the lattice package. All right, so what you'll get is a plot where the points are distinguished by color, and different colors correspond to different genders. There was no intent to use pink and blue here. That's just a coincidence. But actually, I'm not 100% sure that blue corresponds to male and pink, or it's actually magenta corresponds to female. We'll see in a second how to create a legend or a key to identify that. But before we get to that, what I want to point out here is that whenever we use a groups variable, it is, if you think back to what I said at some point, I believe, I said that the default panel function for XY plot, I said, is usually, or I might have said always, is always panel.xy plot. If I said always, it was a lie, because whenever you have a groups argument, looks like I'm having a couple audio problems here. Let me see. Okay. Hopefully that'll get better in a little while. So anyway, whenever you have a groups variable, like we do here in chunk number 15, the default panel function is actually no longer going to be panel.xyplot. By virtue of having used a groups variable, the default panel function is now going to be something called panel.superpose. And panel.xyplot, which remember that makes a scatter plot, that will still be used, but now that's going to actually get passed in as the default value for something called panel.groups. All I'm trying to show you here in chunk number 16, it should give you the same result as we had for chunk 15. And so I'm just showing you in chunk number 16 that these two lines here correspond to the default values that were implicitly selected in chunk number 15. Okay? So those are the defaults. I'm going to explain how those defaults are working now. Basically, when you have groups, actually, let me take a step back. Remember how the panel function worked. The panel function was a set of drawing instructions to be carried out separately within each panel, right? Panel.groups takes that a step further, and it's going to give a set of drawing instructions to be carried out within each group within each panel. So first it's going to, if you look in the lower left here, this corresponds to month 0. First it subsetted out all the month 0 data, and then it subsetted out all the, it would have done female first actually, because F comes before M in the alphabet. Substituted all the female data, and then it said, all right, now that I've got this group within this panel, what do I do? And that was determined by this panel.xy plot, and so it just made a scatter plot with those values. And then it moved on to the next group within that panel, which was the males, and it made a scatter plot with them as well. It might seem a little abstract, and I think it will get clearer as I start to flesh these examples out a little bit more. If I go on to chunk 17 here, now I'm going to say I'm going to add a little bit of pizzazz to my panel function. I'm going to add a low S line, and so let me just go ahead and do that. And let's look at what happened here. The panel function said, all right, for each data set that you get within a panel, go do whatever panel.superpose does, and then make a low S line. And that's why within each panel here we only have one low S line, because that call to panel.lowS came within the panel function. Okay, and here's where I hope this will help distinguish how panel and panel.groups works. If I take that call to panel.lowS and I move that, so I'm going on to chunk number 18 now. I move that, notice the difference between chunk 17 and chunk 18. Now I'm moving that panel.lowS call within the panel.groups argument. So now that set of instructions, the instruction to draw that low S line, that's not just going to be carried out within each panel, that's going to be carried out for each group within each panel. Okay? So let me pause for a second here and see if you have any questions about what the difference is between chunks 17 and 18. Or is that clear to everybody? All right. So I don't see any questions, so I'll assume that's clear. Now, a natural thing to ask here is, all right, well, now I do know, I have a legend or a key up here. That got added because of this, this line here. So auto key equals true. And so now we find out it's actually the women who are labeled with the blue dots and the men with the pink dots. But why didn't that work for the low S lines? Okay. The reason is that information about which color to use and which line type to use and all that, that gets passed down. Basically, XY plot, at the level of XY plot, it knows what colors to use. And it's going to pass that information to the panel function. And the panel function is going to pass that information to the panel.groups function. And the panel.groups function is ready to take all that extra information about color and line type and so forth. It's ready to absorb all that information because it has this ... argument. And so when we made our scatter plots for each group, we passed along that ... information, which included all the colors and all that. But notice that when we did panel.lowS, we didn't include that. And so what happened was, even though panel.groups received all that information about which colors to use and so forth, it couldn't pass it along to panel.lowS because panel.lowS just our call to panel.lowS did not allow for, it didn't have a ... argument where we could pass that along. So as we move down to chunk 19 here, the only difference is I've added in that ... in our call to panel.lowS. And so now the color information will be passed along to, will be used when we call panel.lowS. So let's take a pause here and think, what are the groups doing? Well, they're doing two things. They're differentiating using color and plotting symbol and line type and so forth. But they're also grouping the points together in a way that, for example, when a lowS line is computed, it's only going to be computed on a per group basis if we have it, if we're calling it here within the panel.groups function. Okay. So now, a natural question to ask now is, well, that's fine. That color information got passed along. Now I can differentiate which, which are the males, which are the females. I can see which line goes with which dots and all that. But what if I want to use different line types or different plotting symbols? And so that's what's going to be addressed by the second half of this lecture here. And so this is all about what's called themes. So I'm going to move on to that question of how to change colors and line types and so forth. Before I do that, any more questions about how groups and panel.groups works? I feel like I went through it a little bit quickly. But looks like there are no questions. So, all right. So these colors, where do they come from? They come from something that gets automatically set whenever you start up Lattice, and it's called a theme. And if you want to see what that theme looks like, if you want to visualize it, an easy way to do that is there's a built-in function called show.settings. So if I run that, it just shows you a bunch of different things here. And let me take a second to talk about what these things mean. Basically, the ones that I end up dealing with or thinking about the most are the superpose.symbol and the superpose.line. And they both work the same way. The superpose should clue you in to the fact that these are colors and lines that are going to get used when you're using panel.superpose, which is to say when you're differentiating by groups. And what happens is it will XY plot, or whatever lattice function you're using. For the first group, it's going to use, in this case, whatever's on the bottom line of superpose.symbol, which in this case is blue circles. And then when it wants to plot points for the second group, it's going to use these magenta circles. And then if there had been a third group, it would have used the green circles. And it's going to be the same thing with lines. It's just showing you bottom to top the way it's going to progress through different colors as it progresses through the groups. If you want to see, now this sort of doesn't tell you the whole story. Right now, all you see is things changing by color. But if you look at the way that this information is stored internally, and we can do that with this function trellis par get, so it means get the trellis parameters associated with superpose.symbol. So in the plot over here, you see superpose.symbol. Where all this stuff is, where all the information about how to make these points is stored is, or the way that information is stored, we can see that when we execute this trellis par get, and we give it the we tell it we're specifically interested in superpose.symbol. So what does this show us? It shows us that these points, what you'll notice is there's a list of a few things. Alpha, I can talk about alpha in a second. Let's focus on color, okay? COL. This COL is a vector of length 7. And if you count up how many rows there are in the figure, how many rows there are for superposed symbol, there are 7 of them. And it's, unfortunately, a number of these colors are specified using a hexadecimal format that's hard for humans to interpret directly, but some of these colors are also specified using just color names. Like the third one is dark green, and if you look over here where we're showing the settings and you count up to the third row, you can see that those circles are dark green. Okay, that's the reason that those circles are dark green, is because this third element of the call vector was dark green. And likewise, the fifth row is orange, and so forth. Okay. By the way, just a little side detour. I often, there's tools you can use to kind of mix your own colors and to get hexadecimal specifications for custom colors and stuff like that. But I usually just use the built-in color, named colors. And if you want to know what those are, you can just use a little function called colors, and it'll just list all the colors that have that are named, basically. A lot of grays in there. So you can just try, play around with those and try them and see what you want. That's one way to do it. There's also something called palettes, which I'm not going to get into, but when you're trying to find a set of colors that might, go together nicely, there's you can just look for help on palette, and that might help you a little bit. But that's a little bit of a side detour. I can tell you more about that offline if anybody has questions, but what I want to emphasize for now is just that is just how these default colors and things are how that information is stored. Okay, it's the same thing for trellis par get superposed line. Okay, in that case, we're going to see the same colors, and that's confirmed in the plot here. It's the line colors advance with the point colors. There's no nothing about that is enforced. So you could, if I don't know why you'd want to do this. Well, actually, I can think of a reason why. You could, for example, you might want to differentiate the points using color, but you might want the line to be gray for every single group. And in that case, you could just set all of these colors to gray or light gray or whatever. So there's nothing that enforces correspondence between the point color and the line color. What I want to show you now is how you can set these things. So we were just looking at trellis par get, which queries the current value of these parameters. Now we're going to play around with trellis par set, which sets them to new values. Before we do that, and I should have done this in the script, but it's not a bad idea to capture all of the current information. Let's call it, we'll call it old theme, or maybe we should call it default theme, meaning whatever theme we had when we started up R. And I'm just going to do a trellis par get, open paren, close paren, and that's going to get all of the current theme and store it in an object that I'm going to call default theme. The reason I'm doing this is so later, after I've mucked around with the theme a bit and messed things up, I can go back and I can restore this default theme. Okay. Just to jump ahead here, once I've gone and messed things up, the way I'm going to retrieve the theme that I have now is I'm going to do trellis par set default theme. Now in this case it's not going to have any change because I've already got the default theme active, but later I'll be able to use that to return things to the way they were. Okay. All right, so now that we've got that information saved, let's go ahead and muck around with these things. We can change, instead of using these open circles for every point, we can change the plotting symbol, or what's sometimes called the glyph, using PCH. So I'm just going to use, so open circle is PCH1. I'm just going to set it to PCH 1 to 7, and you'll see what that looks like in a second. So I'll run that. And also for the lines, we had all solid lines here, but there are other line types that you can specify with LTY, and I'll just let those go from 1 to 7 as well. And now, if I go back and try to show the settings again, you can see that I still have open circles for the first group, but then it goes to the triangles and the crosses and so forth. It's the same colors as before because I haven't messed around with that parameter, but the glyph has changed, and also the line types have changed now as I progress from one group to the other. So that's a result of changing the theme. Now, of course, the point of changing the theme is not to get this show.settings result to change. The point is to change all our scatter plots and so forth. So if I go back and I make that scatter plot that we had previously, this is the same code as we ran a couple code chunks back. Now you can see that the men are no longer represented with pink circles. Now they're represented with pink triangles, and that's because of that change we made to the superpose.symbol setting. And likewise, the line type has changed for the second group as well. And I already mentioned this, but it doesn't hurt to mention again. The men were selected as the second group here because they are the second, by default, they're the second in alphabetical order, basically. So if you didn't want that, I think we've seen this before, but it doesn't hurt to show it again. You've got, you could say dat, the variable is sex. I could change that to be a factor. I'm going to use the same information, but now I'm going to say the levels, I want the levels in the opposite order, so I'm going to put M first, and then F. And if I did that, and then I remade my plot, you can see that now the men are the circles and the women are the triangles. Okay, so that is the best way to change how the numeric information gets, or the underlying data information, how it gets mapped to the values in the theme, is by manipulating the factor levels. Okay, so the factor levels determine the order of the groups, and then those get associated with the rows that you saw when I made that show.settings picture. Okay? All right, I'll pause for another second here. Any questions so far? It's I don't know how it is where everybody is right now. It's a rainy day here, so I don't know if everybody's in kind of a slow rainy day mood. Okay, here we go. Sometimes, okay, this is a question we see all the time of why am I sometimes using single quotes and sometimes double quotes? I could have used either. Okay, I could change these to double quotes and it would work just as well. In fact, I can even mix and match. It'll still work. The only reason to prefer one over the other, well, actually two reasons. One very insignificant reason is I will usually default to using single quotes just because then I don't have to press the shift key, but that's not much of a reason. A more significant reason is if you have if you're using let's say single quotes and you want to say that is Tom's dog, because the apostrophe and single quotes aren't distinguished here, it doesn't, R is going to think that the quote ends, R is going to think that this highlighted part is the extent of what I want to quote. Now, a way around that is I could put a backslash here, which backslash is the escape character. And now it's going to know, let me cat out this string here. Now it's going to know that that I'm trying to print the whole thing. If I hadn't put that escape, it's going to give me an error, I think, because it says, all right, you want to cat out, basically print out this string, and then this stuff that comes after the string, I don't know what you want me to do with that. So that's one solution, is I could use the backslash escape character. But the other solution is I could just use double quotes, and then there's no ambiguity about, that internal apostrophe or a single quote. And so it's just a convenience, really. Likewise, the reverse logic applies too. So, it might, if you want to say, he said, double quotes, hello, you can do that within single quotes. Okay? But if you tried to do it within double quotes, you'd have to use the escape, the backslash, to escape the double quotes. All right, can I give one or two examples of this theme function in pharmacometrics? Yeah, sure. So, well, here's an example right here. I mean, it's not implausible that you would be looking for gender differences in an exposure-response relationship. And if you just used the default theme, the one we had initially, you would get all of the points and all of the lines. The only thing that would distinguish males from females would be color. And so then if this is going to get printed on black and white or whatever, for certain regulatory documents, you have to be able to distinguish with something other than color. You want to be able to manipulate that. You don't want to go with the default setting. Another example would just be, if you use this default theme and then you're pasting things into a PowerPoint, these points end up being pretty small. So you might simply want bigger points, and you can change that via the theme. In fact, if you're really clever, you can have one theme that's set up for your PowerPoint presentations and one theme that's set up for your reports, and so forth. And different settings are appropriate in those different scenarios. So I don't know if that answers your question, but those, it seems like a fairly minor detail. This kind of mundane stuff about how to play with colors and stuff, but it's stuff you do need to deal with. So that's so I think it's important to know how to manipulate it. Hopefully, those are a couple examples. It's also important, and this is what I want to show in this last example here, to understand how lattice makes the legend or the keys. So you can see, all we did was we said make a key, auto key equals true, and it figured out the right way to, how values were mapped. What you want to understand, though, is it's possible to trip it up. And here's an example how. What I'm doing in this chunk number 26, this is an example of something that you should not do, okay? Actually, let me first comment out this auto key line. Let's say, for whatever reason, I want to use, instead of blue and pink, I want to use green and blue to distinguish sex, okay? So I can, instead of mucking around with the theme, I can specify that right here in my call to XY plot. And I can also specify the glyphs that I want to use. And that will work. So let's execute that. Okay, I get the green and the blue, and that's all fine. The thing to be aware of, though, is that when you go and you add the key is going to be computed based on whatever the theme is. So now when I add the key, it's incorrect, because auto key is going to say, it's going to assume that you just used whatever was specified by the theme. So it's going to say, all right, well, group the first level of the group would have been assigned blue circles because that's the active theme, and the second level would have been assigned pink triangles. And AutoKey basically doesn't know that you specified these other things on the side here. So that's not a good way to do it. The better way to do it is by manipulating the theme. So I could have, instead of doing what I did here, hopefully you can see based on the examples we did previously, I could just change the value of these parameters in the theme, and then if I do it that way, then my key will always line up correctly with the data. And in plotting, you know, the reason I love plotting, and I think a lot of why it's often so great, is it's very hard to screw up a plot. It's very hard to get it wrong without realizing it. But the one way you can really get a plot wrong and not realize it is by messing up the key. So that's an important thing that you want to make sure you get it right. And again, the best way to get the key right is to use AutoKey, but and then to manipulate colors and so forth using the theme. So hopefully that makes sense. I'll take more questions here, but why don't we get you guys going on some of the exercises here in the homework and see if you can put these ideas into practice. So give these a shot, and I will. It looks like we're going to have time where I can probably work through the solution during this lecture here. So the first, it won't really be homework. The first exercise, plot response versus month, conditional on dose. So that part should be easy. And now here's the more challenging part that's going to force you to think about using panel.groups and so forth. Use thin gray lines to connect data points from the same patient, and add a thick black line that connects the mean responses for each month. So why don't I give everybody about 5 minutes to make an initial attempt at that, and then I'll come and give you my solution, and that'll still leave us about 10 minutes to handle the second problem there. And in the meantime, if you guys want to post additional questions, I'm happy to answer those. Okay? I'm gonna, for anybody listening on the recording, I'm gonna pause it here until I come back. Jump back in here and start trying to work through a solution. Okay, so again, the first part here hopefully was not, hopefully you know how to do it by now. This would be XY plot, response versus month, and conditional on dose. So let's just make sure that works. Oh, we got to specify the data frame. Data equals dat. Okay, that's fine. Might as well make it, give it a more, well, that's fine as is. You can change the layout if you want. Use thin gray lines to connect data points from the same patient. So let's tackle that one first. Okay. Well, if we want to basically do something different for each patient, that means we're going to have to let patient, or it's a subject is the variable name. we're going to have to use subject as the group variable. And then we could say type equals L for lines. And we could say color equals light gray. Now you'd have to have looked through to see that light gray was a permissible color, but I know that it is. So okay, so that's fine. Actually, I can see I still have the the line types that I created a moment ago, and I don't really want those. I want all solid lines, so I'm going to go trellis par set default theme. So this will give me back the just the solid lines. Okay, so there's that part. And then the next part's a little bit harder. Add a thick black line that connects the mean responses for each month. So first of all, we need to know how to compute the mean responses within each month. And this is where you got to kind of combine things that you've learned in different lectures in this class. You should have seen, I think it was last time, how to use the function tapply. But let me just kind of maybe refresh your memory on that. So what I'll do to make it easier to think about maybe is, let me just take the second or first dose group, okay, dose 0. So just as a little kind of play, I'll call it play dat, I'm going to take a subset of data where dose is 0. Because this is kind of like what's happening within the, uh-oh, that doesn't look good. This is kind of like what's happening within the call it to XY plot. I seem to have, okay, there we go. Try that again. Okay, and the reason I'm doing this is just to show you now how what we do with playdat is going to be the same thing that we want to do in our panel function, which is we want to calculate the mean at each month. So the way we can do that is using the tapply. So tapply is going to take, I can use response as the thing that I want to take the mean of. I can use month as the index variable, so I want to calculate the mean separately for each, the mean of response separately for each month, and then I need to tell it what operation I'm doing, which is the mean. So if I did that, that's one way I could compute the mean for each month. And so those are the y values. These guys here are the y values I'm going to want to plot. And these guys here are the x values that I'm going to want to plot those against. I can also get those x values by just saying unique values of dat month. Okay? And it doesn't hurt. Now in this case they come out already in order, but unique won't always work that way, so it wouldn't hurt to sort those. In this case, again, it doesn't matter. But so I'm going to do that same thing within my panel function. So I'm going to say panel function of x and y and other stuff, and I want to do a panel.superpose, because that's what's going to say, okay, go do whatever you need to do for each group, go do that. But I'm also going to do something that's not group specific, which is just calculate the overall mean. So that's not a group specific mean. That wouldn't even make sense. It's a mean within each dose panel. I want to take the mean for each month. So I can do, let's call it my for the mean y value. I'm going to get that by saying t apply. Y is the thing that I want to take the mean of. X is the index variable. Just like, same as what I did down below, except now I have y and x instead of dat dollar response and dat dollar month. So that's going to give me my mean values. And then I can get my unique x values by saying sort unique x. And then I can plot them with just panel.xy plot, because this is just basically a scatter plot, but with the points connected. So I can say plot ux against my, and I want to do it with a line, so type equals L. I want it to be black, so color equals black. And let's make it thick, so LWD stands for line width, so let's make that 2. And that should do it. Okay. So we've got a little bit of time remaining. Go ahead and, well, since time's a bit short here, you may or may not have time to solve this completely, but just take a couple minutes to try to do homework problem 2 here. Or if you want to use the time to ask me any questions about problem 1 or whatever, that's fine too. That may or may not have been enough time for you to try to scratch out a solution, but hopefully you at least were able to start there. But since time's running short, let me go ahead and give you a solution that I have. Okay, so homework 2. Okay, so hopefully you got the idea from class that the best way, since we're trying to change plotting symbols and colors and so forth here, the best way to do this is by manipulating the theme. And you already know that the theme element that we want to play around with here is the superpose.symbol. So one thing that you maybe don't know is how to get crosses instead of circles, unless maybe you notice actually from the previous problem. But if you forget which plotting character is which, you can always do something like this. Plot, this is just the base plotting function. Plot the numbers 1 to 20 and use PCH, plotting character 1 to 20. And that will remind you, that's kind of like an instant guide, okay, to what the different plotting symbols are. So open circle, we already know that's PCH equals 1. Cross is PCH equals 3. Okay? So that means, in terms of setting my theme, I can do trellis, par, set, superpose, symbol. It's going to be a list with PCH equals, and here I want to do, I want a circle, so that's PCH1, and then there's 3 active dose levels, so that's going to be a rep. Plotting character 3, I want to replicate that 3 times. Okay, so that should take care of the plotting characters. And then, actually, I can just, in this same line, or this same command to trellis parse set, I can say COL equals, I want blue for placebo, and then I want to repeat red for the 3 active dose groups. And make sure, okay, looks like my parentheses are lined up okay. And then one other element, I said I want the size to increase. So that's the parameter that controls that is CEX. So I'll do regular size 1 for placebo and for the low dose group. And then I'll go from 1 to 3, 2 and 3 for the medium and high dose group. So that should give us the theme that we want. And let's see if that worked. What are we doing again? Response versus exposure, conditional on month, and dose as groups. So XY plot, response versus exposure, conditional on month, and groups equals dose. Let's see if that works. Dose 2? Oh, that's because I didn't specify the data frame. Dose is fine. Data equals dat. Okay, and so now what you should see, or what you see, is the 0 dose group got represented as blue circles. The low dose group got represented as small crosses. Medium dose group is medium-sized crosses, and high dose group is big crosses. So I don't know, that might be a little bit silly to use in practice, but hopefully that gives you an idea of how to manipulate these things. So that's all I wanted to show. So again, I'll post those, a cleaned up version of these solutions to the course website. As usual, I'll hang on the line for just a couple more minutes here if anybody's got questions. Hope you enjoyed learning that and saw how to make use of that. And I will see you again. I forget which chapter it is, but when we cover the chapter on modeling, that's when I will be back. Or I should say modeling in R. I will be back. So in the meantime, I'll just see you in the course forums and stuff like that. Have fun with this stuff. Okay, bye.